So now we're moving on to 4.2, which is really zeroing in on triangles and whether or not two triangles are congruent to each other. So we're going to learn three different postulates today that are going to identify whether or not triangles are congruent. And those postulates are side, angle, side, angle, and side, side, side. But before we can understand those postulates, we need to have some more definitions. So we need to understand what is an included side and what is an included angle. So it says, with respect to angle A and angle C from the given triangle, so here's the given triangle ABC over here, side AC is called an included side. So with respect to angle A and angle C, then side AC is called the included side. So what do you notice the included side is? The included side is the side that connects those two vertices together. So if you look at the next two letters, it says, what is the included side? What is the included side between angles A and B? So if I'm looking at angle A and angle B, then I must talk about side AB as the included side. So segment AB is then noting it is the official included side. So another way you might think of this is it's the side in between the two angles. So it's the side in between the two given angles. A and B were given, therefore the included side is side AB. Okay, what about B and C? So if we're talking about B and we're talking about C, well, what's the included side? It's the side that connects those two vertices, which is BC. So it's the side in between the two vertices, maybe that's a better name, or angles, because I'm calling them angles here. But you should see that a vertex and an angle, that's representing kind of the same thing in this triangle, because there's only one vertex per angle. Or there's only one angle per vertex, sorry. Okay, what is an included angle? So here, since sides AB and CB, so let me highlight sides AB and BC, intersect at B, angle B is called the included angle. So notice, once again, if this is side BC, side AB, B is the included angle. In other words, it's the angle in between the two sides. The angle in between the two sides, or you could say the angle connecting the two sides. So this angle has two rays. Those two rays are the sides that create the included angle. So if we look at CA and BA, so here's CA, here's BA. So what is the included angle? Well, it's angle A up here. Right? So in other words, you can also see they share the same vertex in common. So A is in common, so that's the included angle. So here, if angles A and B we're talking about, the vertex, or sorry, the side we're creating is this two vertices connected, AB. So BC and AC, you should see immediately, because they both share C, that we should be talking about angle C. Well, let's look on the diagram. Here's BC, here's AC. So what angle do they have in common? They have C in common. So therefore, C is the included angle. Okay, so let's read through these postulates. The side, side, side postulate. It says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So here, BC, this triangle shows us that BC is congruent to EF. Right, that one mark shows us that. And that BA, or AB, is congruent to DE, because it's double mark. And this triple mark shows us that AC is congruent to DF. Now, if that's the case, that means they're included angles. So if this is the case, if these three sides are congruent to each other, that means triangle ABC is congruent to what? Well, I went from A to B to C. So I need to follow these same marks. It just so happens I went in alphabetical order. From D to E, because it's double mark, So I have to go this direction, and then I have to go this direction, and E to F. So it's congruent to triangle DEF. As soon as you make this congruency statement, you now know angle A is congruent to angle D, and angle B is congruent to angle E, and angle C is congruent to angle F. You know all of those conclusions because of this statement. Okay, how about the SAS postulate? This is where included angle comes into play. It says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So look, here's a side AB, here's a side AC. What is their congruent angle? Or sorry, their included angle, excuse me, the included angle. What is the included angle? It's angle A, because that's the one connecting those two vertices together. That's the one in between them. So this is SAS, side, angle, side. So notice how that order, side, angle, side. The angle is connecting those two sides. It's the glue that holds those two sides together. And here we have the same marks. It's side, angle, side. So triangle ABC is congruent to triangle DEF. Now, do we have to write these letters in this order? Did I have to write ABC and DEF? No. I could have followed this pattern. I could have said I'm going to go side, angle, side. So I'm going to start with the letter B. So triangle B, and then I go to letter A, and then I go to letter C. But if I change the letter order here, then I have to change the letters order over here. So I went from B to A to C. Well, that was a single mark, and then the included angle and a double mark. So I have to go from single mark to included angle to double mark. So I have to go from E to D to F. So I must line up these letters properly. B is congruent to E, we can see that here. A is congruent to D, right? It's the same in both triangles, and C is congruent to F. So the location in the congruency statement matters. Your letters have to line up with the appropriate vertices. Your vertices have to line up because those are congruent to each other. Angle A is congruent to angle D. Angle E is congruent to angle B. So what's another way we could have written it? What if I wrote triangle FED is congruent to what? Well, what would I write? If I wrote F and then an E and then a D, what do I have to put over here? Well, if F has to be congruent to C, I have to put C first. And if E is congruent to B, I have to put B second because it's second here. And if D is congruent to A, then I have to put A last. So again, the order of these letters is crucial. Crucial. Okay, let's move on. The final postulate we're going to talk about today is the angle side angle postulate. So if two angles and the included side of one triangle are congruent to two angles and the included side of another, then the triangles are congruent. So remember, if you have two angles, the side that connects those two angles is the included side. So it's angle, side, angle. They're connected. These two angles are connecting that side is connecting those two angles to each other, so that side is the included side. It's the side in between those two angles. So we have angle, side, angle. So if I'm going to write a congruency statement here, I could start with angle D, and I could go through my side and then end with angle F. So that's D and then F, and then I need to also include letter E because 3 points are what name a triangle. So I might go angle, side, angle, but I still have to include letter E, so it's triangle DEF here I'm looking at. So in order to lining up with ABC, well, I have to make sure I'm putting the letter order correct. So you can see D lines up with angle A because they had the same marks there. So this is going to be letter A. And then what do I go to next? I go to letter C, and then I go up to B. So I've lined up the appropriate angles with each other because they are congruent to each other. Okay, so now we're going to practice. We're either going to justify these triangles are congruent because of side, 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 angle, side, or angle, side, angle. So in this first diagram, we know that XW is congruent to YZ. Why do I know they're congruent to each other? Because of the single mark right here. And then I can see that WZ is congruent to XY. Why do I know those are congruent to each other? Because of that double mark right there. But so far we have a side. We have side XW is congruent to side YZ, and side XY is congruent to side WZ. So we either need a third side to prove these triangles are congruent, or we need an included angle, because this has two sides. This one's automatically not going to be an option for letter A. So we're trying to prove two triangles are congruent. Well, I don't know anything about the angles because none of these sides say they're parallel, so I can't do alternating interior angles or corresponding angles or any of that stuff. But what I do see is that both these triangles share side WY. So look at triangle XWY. It has a red side, a green side, and a blue side. Look at triangle YZW. It has a red side, a blue side, and a green side. So for those of you that you're visual learners, this should help you. So look what I have here. I have triangle XYW. So I went XYW. I went blue to green, and then I'm going back to red. So I have to go blue to green to red. So I have to start with Z. Z lines up with X, right? So look at the XYW. I go blue, green, and then back here to X. So I have to go blue and then green. So it's going to be Z, then W. Oops, I forgot my triangle symbol. This is huge. Remember, notation matters. Sorry about that. So I need my triangle symbol. So it's Z, W, and then my final letter, which is Y. I have side, side, side. Side, side, side. So why are these two triangles congruent to each other? The justification is side, side, side. If three sides of one triangle are congruent to three sides of a different triangle, then those two triangles must be congruent to each other. That's what side, side, side says. Okay, let's look at example 2. Here we have KL is congruent to KH. Okay, so we have KL is congruent to KH. And then we have angle LKJ is congruent to angle HKJ, right? So this angle here. So these angles are congruent. Okay, what else can we deduce? Is there anything else we can deduce here? You know, is HJ congruent to LJ for any reason that we have learned so far this year? No. Are these angles congruent? No. What people often miss, but now this is the second time it's happened, is the shared side. These two triangles share KJ. So KJ is congruent to KJ. So we have side, angle, side right here. So here's the blue, red, green. So that's side, angle, side. So my justification for why these two triangles are congruent is side, the included angle, and then the side. Side, included angle, and then the side. So now you have to decide what order you're going to put the letters in. So I start you with triangle K. So I start here at K, and then I go to H, and then I go to J. So I went up the blue streak and then to the blank streak. So I have to start at K. Oops, again I forgot my triangle symbol. Don't be like me. So you start at K, you go up the blue streak to L, and then you go down the blank streak, which is J. So this means that angle LKJ is congruent to angle HKJ. That's this first K that we have here. Or KL is congruent to KJ, which we have that here. We have HJ, JK first and last, JK first and last, because those were congruent. So all of it works. So these two triangles are congruent to each other because of SAS. Let's look at letter C really quickly before time runs out. I only get 15 minutes, so I have 30 seconds. Here I have red, red. These are congruent to each other. AK is congruent to KS. I have blue, blue. These are congruent to each other. My final thing that I know for certain is that these are vertical angles, and vertical angles are congruent. So what do we have? We have side, the included angle, side. So the justification for these two triangles is SAS. What should your congruency statement end? You'll find out in the next video.